We are going to get started here in a couple of minutes. I'm Katie. I'm the admissions manager here for the data science career track. So I'm going to wait until right at noon Central, or noon Pacific, not Central, noon Pacific, and I'll do some brief introductions and then we can get started. So if you are already tuning in, you can hang tight for the next minute or so and then we'll get started. Also, before we do get started, I want to call your attention to the fact that we have both a chat where you're able to post questions as well as an actual Q&A where you can send those questions directly to me as well as to Ryan. And so that way, when we get to the Q&A section of today's webinar, we can make sure to get as many of those questions answered as possible. I will also follow up with any questions that don't get answered in live during the webinar to make sure that you get any answers that you're looking for. Cool. So we're going to get started. Again, Katie, I'm the admissions manager here at Springboard, and we're joined by Ryan, who is a full stack data scientist on the Firefox team at Mozilla. Previously, Ryan worked for Google as well as a few energy market consultancies, and he's worked in data science for a number of years, and we'll talk a little bit more to his own experience, but he's also a mentor for our data science career track. So I'm going to hand it off to Ryan and let him take it away.
Hey y'all, like Katie said, I'm Ryan. This is life as a data scientist and how to become one. All right, let's make sure these slides are advancing. So who am I? Like Katie said, I'm a data scientist at Mozilla. I'm a staff data scientist. I work on Firefox, and right now I've been working on our experimental platform. So how can we run A/B experiments at the scale of Firefox? I go over a quick overview of the topics we'll cover today. We'll start off by describing what data science is, which is a pretty big question. We'll talk about different data science roles. We'll talk about the data science process, so what data science looks like. And I'll give you an overview of what a day in a project from my day-to-day work looks like. I'll give some tips on moving into data science, which is a topic that I think a lot about. And then we'll go over some Q&A. I'll try to leave between 5 and 10 minutes for Q&A at the end. Cool. So getting started. What is data science? So this is a notoriously difficult question to answer. Data science is still very new, and it's a very broad field. It's not well defined, even within one company, and definitely not across the whole industry. I'll take a page from a data scientist that I respect, Hedley Wickham, who's pretty prominent in the R universe. He calls data science the process of turning data into insight. This is a good definition. It's very broad. Again, I think that this includes a lot of things that aren't necessarily data science. So I'd refine this definition to be the process of turning data into insight, especially when the data is very big or when the data is very raw. So for example, the data is very big when it's inconvenient to work with the data on one machine, for example. So this could be if you have terabytes of data and you're trying to pull some information of user counts out of it. That can be very difficult to calculate on one machine. And dealing with this large data moves us into more of a data science space. And when the data is very raw, the classic example here would be working with log data, which is very, very unrefined. It's like a time series of this event happened, the next event happened, this other event happened, and turning that into some measurement of what users are doing on your website or some knowledge that you can take action on is very difficult. Okay. So brief overview of what data science is. Hopefully you have some idea of what data science is. One of the things that I don't really like about the discussion around data science today is that they don't talk about how data science deliver value to the organization, or how users or how data scientists and the organization work together. So here we'll talk about how data science fits into an organization. Generally, an organization or a company will start a data science team when they're having some type of problem that's causing them anxiety. It's difficult to make decisions with a company the scale of, for example, Firefox, and the data science team helps them make decisions at that scale. So I usually characterize this as anxiety reduction for a business, or giving a business senses. And how I describe senses is I work part-time at a brewery, and part of that is you see people come in and they greet you and they say, "I'd like a beer," and you give them a beer. And they sit down at the table and they start talking, and I can tell just from being in the room whether the business is doing well or whether it's doing poorly, and what the draw for that night will be. Uh, Companies that have large global scale like this don't have that option. They don't know when their users are engaging with the product. And if they didn't have some type of data team, they wouldn't have any idea about how well their business is doing. Data science gives you the ability to understand how your business is doing without this direct sense input. So, all right, so here's two situations in which a company will start building a data science team. So when they need to ground their business in reality, this looks like when when a business launches a product that they think is going to be a blockbuster, and it turns out to be either met with no feedback, it just like goes into the void, or they realize that it wasn't the right fit for their users. This is especially a problem in Silicon Valley, where a lot of the people building the products are very dissimilar to the people using the products. They talk about this by saying you are not the user. So data science allows you to test your hypotheses and your biases against reality and make sure that what you're building is a good fit for your users, that they actually engage with it and they enjoy using the tools that you're building or the things that you're building, the service you're providing. Another way that a data scientist can help a organization is by productionizing decisions and insight. So what this looks like, it looks like an executive team who gets bound up because they have to answer too many questions. So what can happen is you can have folks that have really good insight, know how the business works really well, but if you have to go and ask them every time you need to make a decision, it can cause a bottleneck. So if you productionize these things by using metrics that allow you to say, okay, if this number is going up, that's a good thing, go ahead and launch it. You don't need to consult me. Or panic if this number drops in half. That's a major benefit that can help the entire corporation move more quickly. All right, so these are some ways that a data science team can help an organization out. So, all right, you're thinking about becoming a data scientist. It's interesting to know the things that aren't quite data science, but are tangential. So here's your obligatory Venn diagram. You'll see these in a lot of talks about data science and what it is. We have three major vectors: data communication, so being able to explain what you're finding from data. Math, stats, and algorithms. This is statistical knowledge. It's how I usually characterize it, but being able to have the technical skills to work with data. And then software engineering, which is being able to program and build things at scale over many gigabytes of data, terabytes, exabytes of data. So there's a few different intersections here. Data science is squarely in the middle of these three. You need skills in each of these vectors to be able to be successful. Keep moving forward. So those were roles that are like data science, but not quite data science: data engineering and data analysts. There's also, within an organization, when you have a mature data program, you'll tend to have other roles in the data program. So in very small companies, like a startup with a dozen people, you'll have maybe one data scientist that controls the data program, maybe not even full time on the data program. As the company starts to grow, you'll see larger organizations. In the organization, you will find that there's no data science role that describes all data scientists. It's definitely not one size fits all. So you'll see things like business analyst, quantitative analysts, data scientists, data engineer, with all very similar job descriptions and very similar duties. They can all be data science, and they can all be something totally different from data science, which is kind of a problem in the industry right now. Within an organization, you'll tend to have a data scientist who's the person who helps define experiments and manipulate what data, or define what data you need to collect and how to turn that into a decision. You'll have folks who work with data engineering very frequently, and these are folks that specialize in making very large and difficult to work with data sets easier to work with or more available. You'll have data analysts who maybe don't have a lot of statistical knowledge or programming knowledge, but are very good at working with data and drawing insights from it. Then you'll have teams of operations, which make sure that the clusters that you're working with are up and ingestion's working, all that kind of good stuff. There's a bunch of other roles that aren't listed here. These are the ones that I've had personal experience with. So, recapping, I'm moving kind of quick here because we have a lot of ground to cover. But we've talked about what data science is. We've talked about the types of data science roles you can have. We've talked about how data science provides value to a company that you're working with. Those things will help you get a feel for what the day-to-day will be like, kind of, and will help you understand what type of value you can provide to the company. Now we're going to change gears a little bit, start talking about the data science process and what a day in the life of a data scientist actually looks like. So we have a flow chart here. Start at the top center and work your way clockwise. This process starts at defining a problem. So we try to understand what's going on, why we need to answer a question, why folks are confused, what the decision is that we need to make. We move on to prescribing data collection and collecting the data. And then we enter this loop with these bottom two boxes where we try to understand what the data are saying. So we try to explore the data, and then we build some opinion about it, and we move on to analyzing the data. And that cycles for anywhere from an hour to weeks to years, depending on how big the problem is, until you finally have some understanding of what the data are saying. Then you move on to communicating the results and trying to convince folks that you understand what's going on. So that's the data science process. I'm going to talk about a project that I've worked through and guide you through what this actually looks like in practice. So I work with Firefox, like I've mentioned. I didn't work directly on this analysis, but it's really characteristic of some of the work that we do with the data science team. So we launched a feature called container tabs. And what that does is it allows us to, well, it allows the user to have different personas on the internet. So in one tab, for example, you can have your work email. In the other tab, you can have your personal email. And the two aren't, you don't need multiple logins to figure it out. You don't need to worry about the cookies being shared between these. The feature is really useful and cool, but it's a lot of people who use the internet won't use this feature. So it's important to make sure that it's not causing undue complication in the software, and it's not confusing our users. So let's work through this example through the data science process and see if we can characterize what it looks like. A little bit too far there. So we have container tabs. Somebody has built this and they bring it to the data science team and they say, I have this new feature. I think it's really cool. I want to see if our users like it. So I'll start by trying to understand the problem at hand, the question that we have. And that looks like setting a meeting with the owner and trying to figure out like what the feature does. I've given you a quick summary. You probably don't fully grasp what's going on. I certainly didn't understand from the email they sent. And I asked them questions like, okay, why do you think this thing is good? What are the risks? What could be the problem? Why are you questioning whether or not it's good? And how could we win? Like, what's the benefit to the user? What makes this great for Firefox? And that can take anywhere from like a 30-minute meeting to like weeks of reading over docs and trying to figure out what's going on. But once we understand the question at hand, we try to frame that very clearly. And we start with prescribing some ways to collect data. So at Firefox, one of the things that we struggle with is that we are a very privacy conscious company. And until recently, we haven't collected much data at all. And even now, we collect very, very coarse data that isn't very identifiable. So it's difficult for us to say anything about the user in particular. We can only talk about aggregate numbers. So we talk about, for this project, how can we collect some information? We need an experiment because we're trying to decide something about causation. We're trying to say that when users use this feature, they're more engaged. And that link requires us to do some experimentation. So we talk about how we can run an experiment while still preserving user privacy. At this point, we've had some experiments defined, and I send that off, and the engineers go and conduct these experiments, collect some data. And then they bring this back and they say, okay, here's a pile of data. What do they say? And this can be the most fun and the most frustrating part of the process, because there's not a well-defined way to draw meaning from data. So it's a little bit of an art, a little bit of a craft. So for example, this can look like you load up the data and the first thing you're gonna do is like, just how many are there? How many rows are there of this data? And what do the columns look like? So that's some exploration. And then you'll say, okay, well, there's that many columns, then there must be so many users involved here. So you do some analysis and you say, how many users are in this data set? And then you notice something and you make another assumption. You say, okay, well, let's see what happens to the mean engagement. Let's see what happens to how many pages everyone opens up on average. And then you can start to draw more conclusions and you get more and more colorful feedback from the data until you feel like you have a pretty solid understanding of what's going on. I'll say that pretty solid understanding of what's going on is very hard to define, but comes with time and mentorship. So, all right, we've gone through this loop of understanding the data. We've made assumptions. We've explored the data iteratively until we understand what the data is saying. Now we move on to providing value back to the company and communicating our understanding of the data. So a lot of the times, in my experience, my deliverable is a report, which is like a long document with data inside of it that's annotated to provide a launch or no launch decision. This is good and we should send it out, or this is broken and we should definitely not send it out. That can be difficult to do because you need to speak from a position of authority, which means you need to be using data to drive your decision. And the other part is that you need to be able to understand why you made a decision 10 years from now, which is really difficult because you don't know what problems you're going to be thinking about or facing in 10 years. I call this archival quality reporting, and it's important to be able to write a report that whose meaning doesn't change in time. Right. So you want to be able to document the decision well enough to reverse the decision in 10 years from now. So we've talked about one project in data science and what that can look like, what the mode of the work is. Let's talk about the tools that we use. So currently I'm using Python. Previously I used R for like 3 to 5 years. I like both languages, so I won't get caught up in the middle of the language war. I will give some recommendations on which you should start with if you're looking to get into programming later in the presentation. But the team that I work with now supports Python natively and has a lot of tooling built around it. So I use Python instead of R. Spark and PySpark are tools for working with data that's very large. Firefox, we deal with terabytes of data per day, and we look at historical information pretty frequently, so it starts to become very, very big. Spark and PySpark allow us to distribute that over giant clusters of computers that we pick up from AWS. All of this tooling is open source, which is really cool. So if you want to take a look, you can. It might be a little difficult to get running until you have some feedback from the team, but we're there and we're available. Okay, so we've talked about how we compute over scale. We also use Jupyter notebooks for exploration. If you look at some of my writing, I have a love-hate relationship with Jupyter. They're great for exploring, and there's really not many tools that are just as good. But for presentations, I tend to use Markdown in a Git repository on GitHub, which is great. It's standard tools. A lot of people know how to use them, and it's great for getting review, which is super important. If I'm working with something where I need to get feedback from an executive team or folks that don't work in a technical space, I use GDocs. So, brief overview of the tools that we use, or I use at least. Some folks use different platforms for distributed computing, like alternatives to Spark. Some folks use R. It's pretty wild out there what folks use and don't use, but this is what I use. All right, moving on. Cool. So we've talked about one project end to end, but usually when I'm working on, so for 1 week, usually I'm working on anywhere between 3 and 6 projects at the same time, because this data science process can take weeks. I want to be diversified, so I can be pumping out results every week. So we'll talk about what a standard day looks like. A day is going to consist of several different projects at one time. So my day is roughly split between these three categories that I've put down here. Analysis will be actually crunching numbers and trying to produce summary statistics that describe the behavior of our users. This is the nitty-gritty of data science and what most people think of. About another third of my time, though, is spent in meeting and scoping analyses. So this is stepping in, finding the new feature owner and saying, what's going on here? What question are you trying to ask? Trying to help them phrase their question in a way that can be answered with data. That can take a lot of time, and it does take a lot of time. So be sure to be aware that you're going to be consulting a lot, at least in my experience. And then another third of my time is spent reviewing other folks' analysis, which is one of the great benefits of working for a larger company, being able to get review and be sure that there aren't obvious mistakes in your analyses. And then answering questions for folks. Because you're working as a consultant frequently as a data scientist, folks will hit you with very quick questions, like 30-second, hey, how many users do we have in Germany? And I'll tap out a query and send that out. But even though each analysis takes very little time, overall, it takes a significant time of your part of your day. All this to say, about 2/3 of the day is spent talking to people and giving direct feedback and communicating with folks. About a third is doing the actual analysis and number crunching. This mix changes with seniority. More junior analysts tend to do more analysis. More senior folks tend to spend more time talking, scoping analyses, and doing reviews. That's a lot of talking. So that is a day in the life. So this is what it looks like for one day as a data scientist. Okay, we've covered what data science is, how data science provides value for an organization, the types of data science roles you could work in, and then we've talked about what the actual work looks like. Okay, so this is all summarizing where we've been so far. So hopefully you have an idea now of what it looks like to be a data scientist, what the mode of the work is. Now we'll start talking about how to break into data science and what the interviewing actually looks like. Like I said before, this is something that I really like to think and talk about. I've done a lot of data science interviews. I've conducted a lot of interviews, probably north of 150 data science interviews. And I've tried to get really good at these things, which is not very common. Be aware that folks conducting data science interviews are data scientists for most of their day and then do interviewing maybe once a week. So it's not always a very clean process. So talking about breaking into data science, I have highlighted here 4 vectors for skills that are important to data scientists. And these are probably things that you will be evaluated on either directly or indirectly in a data science interview. Again, this is my experience and changes from company to company, but I think this will give you a pretty good understanding of what you need to understand. Actually, let me go over these here. So we have 4 categories: technical, statistical, communication, and data intuition skills. I'll go through these one by one. So technical skills. I mentioned that I was going to go over this earlier in the presentation, but programming languages. So technical skills are characterized by programming primarily. These are things like having some programming skills, being able to manipulate a computer to produce results for you. One of the central questions you'll get is R versus Python. There's a lot of literature about which one to choose, which one's better. They're both good. The important thing is that you need to have at least one somewhere. So you need to have proficiency in at least one of these programming languages. It could be some other language as well, but R and Python are the most prominent in the data science world. Like I said, I've used both of these. I can make some recommendations on which one to start with, but don't choose me as your only authority. Go ahead and do some reading online. Python is my general preference for someone getting started in programming. I characterize 2 languages by saying that Python's maintained by computer scientists, while R is maintained by statisticians. And this permeates through the entire usage of the tool. Python is more general purpose and you'll pick up better habits for programming if you start with Python. R, it's a lot easier to see progress in data science and analysis because it's maintained by statisticians, so it's built explicitly for that goal. If you want to see really quick returns, you can use R, but it might be a little harder to generalize outside of R if it's your first programming language. All that to say, you need one programming language, and that'll be important. I've listed SQL here, and this is kind of separate from the from the programming language question. SQL is the lingua franca for working with data. You'll see folks, going out of focus. So generally, when folks talk about manipulating data, they'll put it in form of a SQL statement, just because it's very common and everyone has some idea about what you're talking about then. SQL goes very deep, and there's a lot of different syntaxes. Just be able to do standard group bys and aggregations, and you should be all right for most interviews. If you get into window functions, more advanced stuff, that's great, but you can usually learn that in the job, in my experience. And then data visualization, I'll talk about a little bit here. It's a pretty common misnomer that folks think that they need to be an expert in data viz before they can be a data scientist. I think this is not a great way to think about it. Data visualization is its own field that you could spend 5 years becoming a master in and still be kind of new. It's important that you be able to produce some visualization, but it's probably not something that you'll be interviewed in primarily for a data science gig. Be prepared to make some exploratory data analysis or data visualizations. These are things like what's like scatter plots and that type of basic stuff. Interactive presentations like you see in the front page of New York Times are very useful for displaying information, but most of what you'll use visualizations for are exploration. So all this to say, focus on tools that help you explore. These are things like ggplot2 or other local imaging libraries, stuff like D3 or better for presentation level graphics that are useful, but probably not what you'll be working with as a new data scientist. Cool. Oh, and this vector software engineers tend to be the strongest candidates. Statistics, I've broken this out separately from technical skills because it's something that you're definitely gonna get some questions about. Within organizations, a lot of data scientists function as statistical consultants. They'll be the guy who knows, or the guy or the girl who understands stats. And people will come to them just say like, hey, am I thinking about this data problem well? There's 4 or 5 fallacies in data that almost everyone commits at some point, and they can be very rife within companies. So you can provide a lot of value just understanding how to work with data and how to avoid these fallacies. And a lot of data scientists provide all of their value just by consulting like that, preventing people from making data fallacies when they're making decisions with data. It's important that you have some understanding of statistics. And if you've looked at statistics, like maybe 10 years ago you took a class, or 5 years ago you took a class, be aware that the field is changing. Folks are focusing more on resampling, which is a little bit easier to grok for people who aren't from a mathematical field. It's a little bit more general. It takes a lot more computing power, so it requires some programming knowledge to use effectively. But it is a lot more fun to use than the magic formulas that they were teaching 10 years ago. You should be able to understand some classic statistics like hypothesis testing. And we'll talk a little bit more about some other statistical fields in a bit. When you're learning statistics, there's this classic divide, very much like R and Python being split. There's this divide between frequentist and Bayesian statistics. I'll note that most of my peers that I've worked with as data scientists are frequentists, and usually there's more learning material about frequentist statistics out there. One data point, don't overgeneralize from it, but it's fine. You should understand what an experiment is, so why one would run an A/B experiment, for example, and what value you get out of doing that extra work to make it a controlled experiment. Okay, so that was some topics and statistics you should feel comfortable with. This is a lot of information. I mentioned this separately from technical skills because you're going to be evaluated on some statistical level. Part of that is because it's very easy to test, which makes it a very satisfying interview question to ask somebody as an interviewer. And part of it is because it's very critical to the job. So expect something along the lines of a coin flip question, for example. If I flip a coin 100 times, how do I know if it's fair? It's going to happen somewhere. And in this field, this is something where statistics or statisticians tend to be the strongest at statistics, as I'm sure you could have guessed. Moving on, this next field I've called data intuition. This is more difficult to define, and accordingly, it's a little undervalued by the industry, I'd say. So data intuition, I've tried to describe it here as having instincts for what you can and can't pull from data, right? So if somebody gives you a data set, you should understand, okay, I think I know what type of results we can draw from this, and what you're asking for is not going to happen from this data set. It also allows you to decide what avenues to explore next. Like I said with the container tab example, somebody brought me a data set and said, I need to draw this conclusion from this data, or I need to decide if this is good or bad. How do I explore this to know what's going on? And then being able to view other people's analyses and say, did you be sure to consider this strata here? And being able to do sniff tests on other people's analysis so that you can review quickly and help folks get to the right conclusion. All of this I consider data intuition. This, unfortunately, is learned with practice. This is all stuff that I've learned through stubbing my toe on data problems 100 times and then learning how to avoid them in the future. Because it's more nuanced and because it's harder to test for, I think it's undervalued in the industry. You may not get this in interviews, but it's still important that you have this skill to be successful. And this is one of the areas where data analysts tend to be the strongest. These are folks who are working with data day to day, but maybe don't have a lot of statistical experience or haven't worked with programming languages much. All right, data intuition. Moving on to the final point, or final vector I call communication. So I've talked about this a bunch. I said about 2/3 of my day is spent talking with people and explaining or drawing information from them. And I've mentioned that an entire part of the data science process is taking the results you've gotten and communicating them out to the company. It's important to be able to write well, in my experience, because data scientists tend to be a understaffed part of the company, often because there's not a lot of data scientists on the market right now for the amount of demand, the amount of data that's being generated. Writing is important because it scales well over different readers. You're going to need to communicate to executive teams, to project managers and product managers. You're going to be able to communicate to engineering teams, and all of this works a lot better if you can write it down once and send someone a link instead of rephrasing what you've thought about 5 times to 5 different people. It also provides or helps you produce archival quality reports that age well, so you can make a decision today and you can describe to yourself in 5 years what was going on 5 years ago. For this, I can strongly recommend On Writing Well, which is a pretty classic book on writing nonfiction. It starts off with giving you good form to your writing and will give you a lot of light bulbs. Light bulbs will go off as you're reading this book. So writing is important. Another thing that I'll mention to you is that confidence is important, and confidence is important, and it's important to hit the right level of confidence for your audience. So you need to be able to tune the message to your audience. For example, if you're working with an engineering team, I can frequently say, well, if I'm 95% confident, I'll say, they ask me like, how sure are you that this is real? I'll say, about 95% confident, I feel good about it. And they'll say, okay, that's really confident, because these are people who are used to writing tests because their code fails frequently. They know what it's like. But if I'm working with a sales team or if I'm working with an executive team, they often have different levels of confidence. So if you say something along the lines of, yeah, I'm pretty sure that that's the case, they want to hear, no, I'm 100% confident. Every statistician will say you're never 100% confident, but it's important to balance your own statistical confidence against the confidence that they're asking for in the conversation. Another critical part of communication is knowing what to include in the report. You don't need to include every bit of exploratory analysis you do. Be sure to tell a clear story that gives them the important facets, and know that it takes a lot of time to read a technical report. So try to keep it sharp and to the point. Okay. Skill summary. So we've talked about 4 vectors. We've talked about technical skills, statistical skills, data intuition, and communication. Generally, you need to be really impressive in at least one of these vectors, and you need to be satisfactory in the remaining vectors. You can't really be deficient in any of these to do well in an interview, maybe for very junior positions. You have better chances if you have 2 impressive vectors. For example, if you're good at statistics and you have a lot of programming skill, you're going to do very well in the interviews. If you have a lot of data intuition and statistical skills, you could probably make up the rest while you're on the job, and they'll be willing to bring you in and train you. So now, we've talked about interviews and what those look like, the types of skills you need to have. It's also very useful to have a portfolio. And a portfolio is going to show off how you think and write. It's going to validate that you know what you're doing and that you have some background working with data. And ideally, this demonstrates some data intuition, which is, as I said, the most difficult part to evaluate in an interview. So if you have some portfolio that shows that you've worked with real-world messy data, that helps with the interview process. This also helps with getting past the first stage of an application. When the hiring manager or their recruiter is looking at your profile, having a bunch of stuff that looks complicated is useful. And mentorship, if you can find it, is a fast track for getting started on this type of thing. Mentors will provide guidance and accountability, which is very important. So having somebody to say like, yeah, I didn't do any work this week because I've been really busy. Having somebody respond and say like, well, what can we do to get some progress on this? Because I know that you care a lot about becoming a data scientist, is very good motivation. They can also target learning material, and this is probably the biggest win for someone getting started in the industry. So this is reviewing your code and saying like, this section needs to be reworked, and this is why it needs to be reworked. It's very useful because they can provide that taste or that code style. They can also say, for example, if you're having problems with statistics, they can say, read chapter 3 of this book that I'm going to give you, instead of saying, you know, I feel like I'm having some problem with testing. I'm going to read this whole book dedicated just to testing until I find the important part of the book. That being able to ask somebody and have them give you guidance on what to learn next is extremely important and makes you much more effective in your learning. Finally, someone who's been in the industry for a while can help you with career advice. Make sure you're using the right language, talking to the right people. So I am here today because I am a mentor with Springboard's data science career track. It's a program that gets you up and running on bootstraps your career as a data scientist. It gives you hands-on experience in data science. You work on actual projects with real-world data. It gives you mentorship. It gives you a weekly call with someone like me who is interested in mentoring new data scientists, and helps you build a portfolio through your hands-on data science projects. You also have a career service team that'll help you get placed. I'm going to hand it over to Katie now, who's going to talk about some more features of Springboard's data science career track.
Awesome. Thanks, Ryan. So really quickly, one thing that I want to talk about is a new feature that we just launched called Deferred Tuition. So this is really valuable because it means that you would only have to pay a deposit upfront of $1,100, and then you actually get to pay the remainder of tuition after getting a job. So this is a new feature that we just launched this week. It's something we're really excited about, so I'm happy to share more information around it. We don't have to talk about it too much in detail right now, but just another option to explore as you consider whether or not Springboard might be a good option for you as you continue to take your next step in data science.
Cool. Well, I think that's everything for me. Do we want to move on to the Q&A?
Absolutely. So this is just some more information around the career track that Ryan already covered over, but we can dive directly into Q&A. I know there are a bunch of questions. So I think one question is, Ryan, if you could just speak a little bit about your educational background and when you got involved in data science.
Sure. Yeah. So I kind of come from a non-standard background for data science. I went to school for a program called quantitative finance, and that was a program where I focused primarily on stuff like financial engineering. And I graduated in 2010. My junior year was 2008, and that market pretty much imploded. So there was a bunch of people flooding the market in that area, and I decided to pivot. I started working as an economist at some energy market consultancies. So I had a bachelor's in finance, economics, and math, and a little bit of programming skill at that time. So I went to these energy market consultancies, and there we were doing simulations for the US power markets. We would simulate how each power plant related to each other and dispatched in different types of situations. And after like 3 years of that, I worked my programming language up. I had a lot of data intuition because I'd been working with government data sets for a long time. And I applied for a gig at Google, where I worked on their search quality team, where we evaluated the quality of changes to Google's search engine. I also worked on YouTube while I was there. And then, about 2 years ago now, I moved to Firefox, where I was a data engineer for a while because I wanted to tune up my programming skills. And then I recently switched over to the data science team because I liked answering questions more directly.
Awesome. Another question is, there are so many courses out there that are free or that have a cost. Is there a program that you think highly of as that has good value and is a good place to start to learn the basics of data science? This person really loves KD Nuggets as a resource, but would love to hear your thoughts.
Yeah, KD Nuggets is great. There's also the Open Data Science Masters, which is a collection of readings that you can do to produce a very complete understanding. Like I talked about in the mentor section, these things can be very difficult because you need to read everything to be able to get to the end. Programs like Springboard are really great because they provide mentorship and they can focus the learning to the career path that you're particularly interested in. So I've had some mentees that are interested in machine learning. So we've focused more on the algorithmic side, and some people who are interested in working in closer to like business intelligence and answering questions for executives. And the curriculum that you look at there is much different. It's working with real data and presentation skills. So having that mentorship and direction will help a lot with finding value from what you're reading.
Awesome. Another question is about, can you comment on the feasibility of an older established engineer / life sciences individual entering the field? Their concern is that it's hopelessly dominated by 30-somethings. So can you speak to kind of how that might come into play as you enter data science?
Yeah, there are a lot of 30-somethings in data science. I've also often found that data scientists, though, are on smaller teams within companies. So within a company, they don't usually have as strong of an opinion or a mental image of what a data scientist could look like. I've worked with a few data scientists who are older, and the careers tend to be more lucrative, so there's usually not that much of a drawback of making the horizontal shift to a new career. A lot of times you can be making more or the same as what you are as an established person in another career. I hope I'm getting to the question here. This is a little rambly. I'd say that it's very feasible, especially in tech. I've found that folks are very open to different types of persons in data science roles.
Cool. And do you have any advice for managing multiple projects concurrently? Is there a project management tool that you use?
Oh, I could go on for a while here. I like pen and paper mostly. I am a pretty strong devotee of Getting Things Done by David Allen. That helps me stay calm after work, which is most of my process, most of my to-do list management is just keeping me stress-free while I'm managing a lot of projects. Pen and paper, getting things done. I'm a big fan of Task Warrior, which is a command line tool for managing to-dos, and Google Inbox, which is a tool for managing email well.
Great. And do you see a lot of people coming out of academia, for example, graduating from PhD programs to work as a data scientist? And do you think that they would be well suited for the field? This meaning like a PhD, not necessarily in statistics or math, but in a different field, possibly psychology, for this particular person.
Yes, we see a lot of psychologists come because of their background in statistics. There aren't really a ton of statistical PhD graduates that I've seen. I don't know why. That's just my own anecdote. I've seen a lot of successful PhD. So people with PhDs and people who have everything but the dissertation in data science, especially from quantitative fields like physics, a lot of folks from the life sciences working with like medical experimental data. And yeah, so it is important to consider the company that you're working for. I've noticed that PhDs tend to do better at larger corporations that have a research data science arm. Smaller companies tend to be more focused on BI and staying alive. And it can be a bad fit for what the PhD usually wants their work-life balance to look like. Again, in my own experience, so I'm overgeneralizing here.
Can you also speak, I know we talked a little bit about age already, but can you speak to the presence of women in the field of data science? Do you know many female data scientists?
I do know many female data scientists, especially since I've worked for, at least more recently, very diverse, not very diverse, more diverse companies in the tech space. So it's something that the tech community is working on. I know several data scientists who are women. It's not an even split yet, so there's still work to be done.
Awesome. And once someone has a portfolio and they're ready to begin applying to jobs, can you recommend any resources for finding the open positions out there to apply to? And also more generally, can you speak to navigating? I know some people have had issues navigating with like titling across different companies. So maybe can you speak to that and how to find positions that you're a good fit for?
Yeah, this is really hard. So I'm generally a proponent for using LinkedIn and like more guerrilla marketing, like getting to meet people at meetups and asking around for who's hiring. A lot of data science positions never hit the market. So having a pretty good network is important. Navigating job titles, they're very broad, and very frequently the folks who are hiring for data science don't know what they need because they don't have enough data scientists to describe it to them. So you'll see things where people are hiring only candidates who have 20 years of experience with a programming language that's been out for 5 years. It's important to not be discouraged when it looks like everything is asking for more qualifications than you have, but don't be afraid to shoot out a resume and see if there's a match. You have even better chances if you can talk to somebody who's at the company beforehand to see what they're actually looking for, what problem they need to solve.
Awesome. And just as talking to building a portfolio, can you speak a little bit to, you were a mentor for Springboard, some of the capstone projects that you've seen and sort of what the process is like building those capstones and why those are beneficial when you get to the job search?
Yeah, so some of the capstones I've seen folks go to meetups and meet people who are looking for data scientists and like work out some contract work on the side, which is really great because then you have a real live data set that has missing values and all those things that happen with data. These types of projects are great because you get to build contacts, and more importantly, you get to build some data intuition. So you actually work with real world data and you pull results from it, and you show that A, you can work with data of this class, and B, that you can communicate it clearly. I think I'm answering your question. If I hit everything? I feel like I'm missing something, Katie.
Yeah, no, I definitely think that's super valuable. And I think a lot of the questions have come from people who they don't have the technical background in data science. And so they're asking sort of, is it actually possible to get into data science without that technical background, and what you need to do to prepare yourself for it?
So building up those technical skills, having some technical background is important. A lot of times you can get entry-level jobs where they'll train you like to become a better programmer. For example, when I joined my second job, I had no experience in programming, but I spent a lot of time working with more senior developers to like build that skill set out. It takes some time and it takes a lot of work, but it's possible if you can find the right gig.
Definitely. As a data science novice looking for an entry-level position to get into the industry, would you recommend going more the startup route or the corporate route?
It's hard. It depends on what you're looking for. Startup routes can be a little bit more flexible. In my experience, I like the corporate route because you generally have larger data science teams, which means you're going to have more mentorship. It's going to help you gain ground more quickly, especially if you're newer into the industry and maybe you don't have a very complete or perfectly complete skill set. Having someone you can lean on to review your code, for example, will be important. Doesn't always happen at smaller startups.
Cool. Sorry, I'm getting a lot of rapid fire questions. So everyone who's asking, definitely keep asking them. I'm trying to read through them and ask them as quickly as I can.
I saw that I wanted to answer. Somebody asked if a Springboard certificate is workable in the industry long term. A lot of data scientists, a lot of companies I've worked for have preferred masters for data science programs, but I'm coming with a bachelor's and I've been very successful. I've noticed that with data science, since the Venn diagram is so common and you need skills in a bunch of different vectors, there's not really great degrees for data science. So something targeted like Springboard's targeted curriculum for data science is extremely useful for getting started quickly.
Awesome. And then I think one other question I just saw that came through was, I know that, so we use some data camp within the Springboard curriculum, but can you just speak to like what maybe some of the differences would be between doing data camp courses versus doing the Springboard curriculum?
Well, I don't know much about data camp, so I'd have a hard time saying. If it's a read-only type of curriculum, if you don't get feedback on the code that you're writing, it's going to take much longer to get to a point where you can write code that looks good. Also, making sure that you have someone who's talking to you about, are you using these statistical concepts accurately, and are you like being subject to any of those statistical fallacies that I've mentioned earlier? That's going to be difficult. Those are going to be difficult fallacies to identify in yourself without some type of mentorship.
Awesome. So we are actually out of time for questions at this point. So we're going to wrap up. I just want to first thank you, Ryan, for coming to this and leading this session. It's been really informative. To everybody who's tuned in, I know you've got a lot of questions. I'll try to capture as many of those as I can and follow up over email. We also have another session next week with Ryan, as well as one of our career coaches from the Springboard side. So, you know, he mentioned that navigating the job search for data science can be a difficult one. And so we actually in our career track give you a career coach in addition to a mentor like Ryan to both tag team and help you find those jobs and help you navigate that. So one of our career coaches will be on as well as one of our alumni to speak to the data science career track and the experiences with that, as well as finding a job. So it'll be solely a Q&A panel. So you can definitely get all of those questions answered. And I will, otherwise try to follow up with you via email. But Ryan, thank you again. And there will be a link to RSVP to that in the follow-up email, which will have the recording of this session. So hopefully I'll see a lot of you guys then. But otherwise, have a great rest of your Wednesday.
Awesome. Thanks, y'all. And I'll look out for more questions.
Bye, everyone.